the ancients devised a way to measure, and by measuring, they were able to construct buildings. Anybody know what some of the earliest measuring devices were that were used by the Egyptians?
Feet.
Yep, they had a string, they put knots in it. And they would come up with a unit of measure, and they would have a line which had knots in it, and by using that, they could lay out a square or a triangle, and therefore they could lay out their magnificent structures which they built. We go forward to today, and now everything is electronic. People sit there and they tap in things, and all of a sudden you go out on a site and find a point. But behind all of that is the electronics of lines and angles and distance. Okay. So in our modern times, using what they would call the imperial measure or US measure or English measure, we primarily use inches, feet, yards. We don't use a lot of rods unless you're a surveyor. Rod's a surveying term that is used. Furlongs, and of course we use miles. So we're going to keep ourselves within those kind of items. We're going to keep ourselves at foot and inches, yards, and miles, and things of that nature. We're not going to get into metric measurement, and we're not going to get into biblical measurements of so much of this and so much of that. But the fact of the matter is that the line, the width of that table that you're at exists. Okay, it has a finite distance from this point to this point, and from this point to this point. How we define that distance is a choice. Now, we could create our own mathematical language here if we wanted to. We could say that this is 3 wasamadoodles by 8 wasamadoodles. And we would all agree what a wasamadoodle was. And then from that point, if we educated enough people on what a wasamadoodle was, we could go out and say, hey, how about building me a building that's 100 wasamadoodles by 200 wasamadoodles? And you would understand. You would understand. But what we do right now is we use foot and inches. So, anybody bring a tape measure? Okay, well, we won't do that. So we're going to be dealing in feet and inches. Now, feet and inches, as we all know, are expressed 2 ways on our construction sites. What are they? Well, no, that's volume. But we use fractions and we use decimals, right? So if I tell you to lay out something 5 foot 6 1/4 inches, okay, I've used foot, inches, and fractions. The other way that I could tell you that is that I want you to lay out something that is 5.56 feet long, which I would be using decimals to represent foot and inches, okay? Inches oftentimes are expressed in tenths or hundredths of a foot. So when we look at this table, you'll see that 1 inch is equal to what? 0.08333 feet. Okay? So everybody take your hands and make about a foot. Okay? Let's do half a foot. All right, that's 0.5, right? Half a foot is 0.5. That's 6 inches, right? Okay? Let's go to 2 feet. Okay? That's 2 foot. Let's go 2 foot forward. Okay? That's the same as 2.33. So we're going to give you a conversion table. I think you've got that in the package, Darcy, where it's a little quick table that'll help you convert inches into tenths and hundredths of a foot. Okay? The way that I learned it is an inch, a hundredth of a foot is approximately 1/8 of an inch. Okay? That made it easy for me. So, it's not exactly right, but it's close. So if I multiply 8 times 8, or excuse me, 8 times 12, what am I trying to do here? Anyway, the point being is that if I multiply it out, it's going to be pretty close, okay? So if I say 12.5 feet, okay, 48 eighths, 6 inches, okay? Okay. Hopefully I didn't confuse anybody too much. I probably confused myself. So We then go to one of the very, very standard measures in construction, which is called a yard. Okay? What is a yard? 3 feet. Okay? How many of y'all have ordered a yard of concrete? Okay, I'm going to order a yard of concrete. Are you really ordering a yard of concrete? A cubic yard of concrete, okay? Why is it a cubic yard? Because it's 3 foot by 3 foot by 3 foot deep. Okay? How many cubic feet are in a cubic yard? 27. Another rule of thumb. Quick to learn. We buy asphalt paving from a paving subcontractor in square yards, right? We buy stone in what measure? Cubic feet, but actually, how do they sell it to us? By tons, okay? So each thing that you go, when you go to Home Depot, you buy things by unit of measures. You go to public supermarkets, buy your groceries, you buy it by units of measure. So it's important to understand what these units of measures are and what they represent. So this table here will help you to convert foot and inches into other units of measure. Okay. When I was in college, there was a guy who was a bit of a smartass, and he decided that on his terminal project, it was a thesis, and that thesis was full of numbers, that he would use an obscure unit of measure called a pickle. Okay. And so a pickle is actually a unit of measure used in steel manufacture. And it represented something like 62 or 68 pounds or something of that nature. So he did his entire thesis in pickles as a spoof because he thought he would be a smartass on his thesis. Guess what he forgot to do? Forgot to put a conversion table on page 1 of his thesis. Guess what his grade was? F. Okay? Because he expressed himself in a way that was not able to be discerned by the professors. Okay? So, we'll stick with foot and inches. Pickles are for hamburgers. All right, that's a rice Elliott joke. Moving along. You've got other things, grains, grams, ounces, pounds, and tons. We don't buy a whole lot in grains. We don't buy a whole lot in drams. We do buy things in ounces. We do buy things in pounds, and we buy things in tons. And of course, we've got liquid measure, and dry measure. We're not going to try to explain every one of these things right now, but what I do want you to pick up, this little table right here is gold. Take it home, run copies of it, put it in a safe place. This little table will help you more as you see things on the job site to understand how to call it something, okay? So, let's go through a few things just for fun. Tyler, what is that?
City block.
All right, how do you buy those?
By the block.
Yep, by the piece. Okay. What's this?
Conduit.
Electrical conduit. Looks like about a half-inch electrical conduit. How do you buy that?
By the linear foot.
By the linear foot. What's that?
Couple.
Okay, how do you buy them?
By the piece.
Okay, all right. What's that on the floor over there?
Bottle base.
Oh, those drinks.
Oh.
That's a case of?
24.
Cutlass. How you buying those? By the piece or the case?
By the case.
Okay, so you see everything we're doing, we're using units of measure. Start to train your mind to see things in units of measure. It's a fun game. You can amuse yourself when you're bored if you're really bored. And but let's look at ceiling tile. Got a leak right there, Darcy. I need to get fixed. But that ceiling tile right there is approximately what size? Who can estimate that? It's two what?
2 feet.
There you go. It's 2 by 4. We throw it out as 2 by 4, right? But it's 2 foot by 4 foot. Okay. How do you buy that? There you go. Okay. So start thinking about things. Carpet on the floor. How do we buy that? By the yard. And interestingly enough, carpet measure, wall cover measure by the yard sometimes is something different than a square yard. Okay. Sometimes it's a linear measure by a 30-inch width or a 48-inch width. So it's important to learn these things. Okay. Because as superintendents and as people within a construction company, and as people who have a desire to improve yourself, at some point in time you're going to get into purchasing. And when you get into ordering stuff, you better know how it's being ordered. How come? because you're looking after the company's treasury and your own, too. So begin that habit, develop a habit. If you'll go away from here today, one of the key points, besides some of the things we talked about with arithmetic and geometry and fine geometry, go away from here with that curiosity about how things are bought. Go away, let yourself enjoy. Let your mind enjoy. Okay? So, I guarantee that there are people in your life that everything they do is measured by unit of measure. Okay, when I was in high school, the dope dealer damn knew what a gram was. Okay? All right? He knew it exactly. He knew what a nickel bag was and a dime bag was. Okay? And he knew what an 8-ball was, et cetera, et cetera, et cetera. Okay? That guy had a set of scales. He was accurate. Okay? Now, if the dope dealer can figure it out, many construction company people can figure it out. Okay? Because we're better than that with what we do. Okay. Now, we have properties of a geometric section. If we could go to our first geometric section that we have, and we'll start with a square. Start with a square. Now you'll notice that at the upper left of your picture for square, come on in. You're in this, come on, have a seat. Get
Hey, Ariel.
Okay, there's a letter there. And what is that letter? A. Is that an A or a D up there? I can't. D. It's a D. Okay, it's a D. Okay. All right, new word for you, new word for you. I may spell it wrong, but it has variable. Anybody know what a variable is?
It's a letter standing for a number.
Exactly. Thank you. Really excellent answer. It's a letter that stands for a number. Okay? So when we look at our D here, it is a letter which stands for a number. So if I tell you, if you would take a piece of paper, they did a little d, didn't they? Not a big D. Okay, little d equals 1, 2, 3, 4, 5, 6, 7. We'll just go there. And we'll call this inches, 2 little dashes. Okay? And what's that bottom dimension, or that bottom letter? D. It's a D too, isn't it? So, let's just call this vertical D. And let's call this width D. And we'll make those inches. Our area, okay, our area, which if you'll look at the right-hand side is big A, okay? And it says A is equal to what? D squared, okay? Now we're actually, that's a square, we're actually using a rectangle, okay, down below, okay, which is actually B, excuse me, I shoot the teacher, call that a B. Let's come down to the bottom. So we've got D, we've got B, area is equal to what? B times D. Okay, area is equal to the area, which from our previous destination, Area is a surface area, remember, it's a surface, okay? It has an area, okay? Big A stands for area. Area is equal to the formula B times D. So, if these are all foot and inches, what is the area of this first rectangle? 1 times 9 equals what? 9 square inches. Might be 9 SI, square inches. Okay? What's our next one? 2 square inches is equal to 16. Third, 3 times 7 is 1. Next.
24. 25.
Thank you. 6 times 4.
24.
Okay. 7 times 3.
21.
21. Okay, so on your piece of paper, let's have a little fun. Go down, make yourself 3 columns. Number from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 80, and 100. Okay? 1 through 10, and then go by tens above that, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's your left-hand column. Make it in a row. Let me know when everybody's got that done. Okay, now the second column, start with 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, 9, 8, 7, 6, and so forth till you get to 1. And if anybody needs to move forward, we need to move the tables forward from out, little hen scratching, be my guest, okay? Get as close as you need to get.
Go for it.
Okay, everybody got that down? Okay, so, what's this called by our formula? D, right? What's this called? Going down the bottom. Calling that B, right? So if we wanted to know the area of that first, what is it? B times D is 100. What's next? $300. 6 times 50 is what?
Not 300.
Not about 300, exactly 300. 7 times 40. I'm walking back down the hill. 8 times 30. 9 times 20, 10 times 10. There you go. 20 times 9. Okay? Fill out the rest of your table. Okay, so if we were to use any unit of measure of 1 in 100, okay, provided those units of measure are the same, we can predict the area. Okay? So, if we had a footing 2 foot long, 2 foot wide by 90 foot long, we would know that the surface area of that footing is 180 square feet, okay? Square feet. Now, where folks get in trouble in construction is that they start trying to multiply inches. Okay, they mix their units of measure. So one of the keys in terms of figuring out area, and next will be volume, one thing to be sure of is that you always are using the same unit of measure in your multiplication. Okay, so real quickly, we're going to use these. 1 inch equals 0.08 feet. 2 inches equals 0.17. 3 inches equals 0.25. 4 inches equals 0.33 feet. 5 inches equals 0.42. 6 inches equals 0.50. 7 inches equals 0.58. 8 inches equals 0.67. 9 inches equals 0.75. 10 inches equals 0.83. 11 inches equals 0.92. And of course, 12 inches equals 1.00 feet. Okay? What would you call what I just did?
Put the two.
Converting to this.
Converting. Okay? So, if I told you here under our D and our B that we had a footing that was 2 foot 4 inches wide, 2 feet 4 inches wide by 90 foot 6 inches, what would be our decimal equivalent to that, okay? 4 inches is what?
133.
So I would be 0.33, so that is 2.33 feet. What's 6 inches? 50, 90.5. So to get the area, I would multiply 2.33 times 90.5. Okay? So when we started this, we talked about systems, right? Who remembers systems? Okay. A system is any way that we do things, okay? It's a way of understanding how things work. For those of you who are late, we talked about a brake system in a car. Okay, there's a electro-hydraulic system in most cars that cause the brake pads to attach to the drums or to the rotors, and it stops the car. Okay, that is a system. Mathematics is also a system. Geometry is a system. A equals B times D is a system. Does that make sense? Okay, so if we learn the formula, okay, if we learn the formula and what the formula means, we'll be able to decipher any problem that has to do with area. Okay. Second thing we've tried to learn is that you must use the same units of measure when you are establishing the length, the area, or the volume of any object. Okay? Does that make sense? So, you got to use the same units of measure. Now, this is one of these confusing things about construction. Okay? We use foot and inches on architectural plans, right? You go to civil plans, what do you see? Tenths. Everything's in tenths. Civil engineers do everything in tenths. And so, you'll look at a civil plan and you'll see a building that is 200.33 feet. Okay? You go over to your architectural plans, and it'll be 200 foot 4 inches. The only difference being that they convert the civil folks, maybe you're ahead of where we are in the architectural world, okay? But the fact of the matter is that this sort of rhythm that you can get yourself into of converting from inches into decimals, okay? If you develop that talent, it helps you be very quick-minded, okay? Now, for a lot of folks who come in here, and some of y'all have been subject to this, when somebody comes in to review an estimate, we really expect those estimators to be able to add, subtract, multiply, divide to 3 and 4 digits and 3 and 4 zeros without the use of a calculator. They have an intuitive feel, okay? Because when you're doing quantity takeoffs, you can put it on the computer and you can take it off and you can do this and do that, but if you don't have an intuitive feel on what that should be, you can make a decimal mistake. And 100 yards of concrete for a slab can turn into 10 yards. And concrete's costing $100 a yard, and when I take 100 and I multiply that times 90, okay, that looks like $9,000 plus sales tax, okay, that's not in the estimate. So these intuitive feels just become something that they develop over time. We expect them to develop that over time. As a superintendent, as a person in the field, you should have an intuitive feel on the length and width of any space that you're in. This building is, okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, that's about 30 feet. Gosh, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 52. Looks about like 50, 30 by 50. Looks like we're in a 30 by 50 space. Okay. Get those intuitive feels going. Develop that habit. Okay? It'll keep you from making a big mistake. Okay. It won't keep you from turning the building the wrong way, which we once had in Huntsville, Alabama. We got the building facing the wrong way. Fortunately, we caught it before the walls were up too far. Okay. We all make mistakes. But get everything converted into the same what? Unit of measure. Unit of measure. Okay. Unit of measure. Has everybody got this point? I feel like I'm being redundant. If everybody's got it, please raise your hand. Okay. We're going to stop at units of measure, take a 5-minute break. You need to smoke a cigarette, go to the restroom.